Hi everyone, thank you for coming. And at this point, we've discussed equations, graphs, a little bit about graphs, and some basic physics knowledge. But now I want to delve deeper into graphs. Now, sorry if my voice sounds a bit off. I am sick right now, but it's okay. Now, one thing about College Board is that they love their graphs. So if you have a good understanding of them and a good concept of them, then answering some of the MCQ questions will be super easy for you. So let's get into it. So the three types of graphs that I'm going to be discussing today are position over time graphs, acceleration over time graphs, and velocity over time graphs. Now for each graph, we'll talk about what the axis means, what the slope represents or means, and what the area under the line tells you. So first, let's talk about position over time graphs. Now in these graphs, the x-axis represents time in seconds, and the y-axis represents position in meters. Now it's important to pay attention to units because the units tell you things about these graphs, so just make sure you're looking at the units. Now for slope, in this case, slope in this type of graph represents velocity. Now if you have a steeper slope like this one here, that means you have a faster velocity. If you have a flat slope like in this situation, that means you have zero velocity. Now we have this slope and it is steep, which means we have faster velocity, but it is a negative slope, or it's going down, so that means it's moving in the negative direction. Now, if you have a curved line like this, that means you have changing velocity, aka acceleration, because acceleration is velocity that is changing. Now, as you can see, the slope approaches a curve towards the end, which means that the acceleration there is getting slower. So it's slowing down. And in these types of graphs, the area below the line doesn't really matter. Now let's talk about a velocity over time graph. So here the x-axis is still time and the y-axis here is velocity in meters per second. Now in these types of graphs, the slope here tells you acceleration. So usually you'll see them like this, and once again the slope is the acceleration. So that flat line that the arrow is pointed to represents constant velocity, which means we have velocity but zero acceleration. Now this line right here, which is approaching downwards, represents a negative slope. And here it tells you that acceleration is either slowing down or speeding up in the negative direction. And a positive or upward slope means that acceleration is speeding up in the positive direction. And in these graphs, the area represents displacement. Now that is really huge to remember. Remember that a velocity over time graph gives you displacement. Another thing to note is that if a line is above the x-axis, the displacement is going to be positive. If the line is below the x-axis, like this part here, that means that your displacement is negative. And from this type of graph, you could also get the total distance by adding the absolute value of the areas. Another cool thing about these graphs is that if the area makes a triangle or a rectangle, you could just use geometry to find the area. Like if it was a rectangle, you just use base times height, and if it was a triangle, you just do 1/2 times base times height. Now the third type of graph we're going to talk about is an acceleration over time graph. Here the x-axis represents time in seconds and the y-axis represents acceleration or meters over seconds squared. Now in these types of graphs, the slope doesn't really matter, but it's the area that is important. Now the area is important because the area under the line gives you the change in velocity, or delta V. Now why does the area under a curve give you the change in velocity? Well, that's because acceleration times time is equal to delta V, or the change in velocity. Now, the same rules, as I stated before, still apply, the same sign rules, that is. So the area above the x-axis represents a positive change in velocity, and the areas below the x-axis, like that one there, represents a negative change in velocity. So some common traps or just general tips when you're looking at graphs are to watch your signs. Just because you're looking at it and you think velocity is negative, that doesn't mean that the object is slowing down. It could just be that it's moving in the negative direction and still speeding up. Another thing is about slope versus area. Remember, slope tells you the rate of change and area tells you the total accumulated quantity. And 3 is to watch out for multiple segments. Sometimes graphs are in pieces or a piecewise graph. Now this means that they have individual sections with different slopes, like they might have a straight section with a different slope. When you get these, you want to treat each section separately so you can thoroughly try to understand the meaning of it. Now, just a quick little summary. A position over time graph, the slope gives you velocity. In a velocity over time graph, the slope is acceleration and the area is displacement. And in an acceleration over time graph, the area is change in velocity or delta V. Anyways, that is it. Thank you for coming, and just remember about graphs, and if you know how to understand them, and it is super easy to just fly through the MCQ questions that have them. Hopefully I'll see you in my next topic.